So dear students, in this session we will discuss trigonometry. Now trigonometry happens to be one of the most important and one of the most interesting topics of mathematics, right? So trigonometry is chapter 11 in your 10th standard state board textbook. So let us see the importance of trigonometry and why trigonometry is used. Now there are 2 or 3 examples given in the textbook, so let us see what they are. So let's assume that there is a student A standing and there is a tower, right? Is it possible for the student A to find the length of or the height of the tower without measuring it? So if there is a tall building or a tower, and if there is a person standing here, is it possible for us to find the height of the tower without measuring it, is the question. Now if you observe this forms a right angled triangle, right? So this is a triangle with 90 degrees, so it's a right angled triangle. So this is one of the examples given here. So the question is, can we find the height? Now what is the other example? A very interesting example which has been given is that there is a tall building, okay, and there is a person, say in the 2nd or the 3rd floor, and there is a river here. There is water flowing river, and there is a pot. There is a flower pot. So the height of the building is known. So if the person is in the 2nd floor, he knows the height, and the question is it possible for this person to find the width of the river knowing the height? So if he knows that, say let us assume that the height is 20 meters, so he is standing at a height of 20 meters from the ground, and there is a flower pot on the other side of the river. Now is it possible for him, for the student to, for the person to find the width of the river, to calculate the width? Is it possible? Is the question. So there is another interesting example which says that there is a little girl who finds an air balloon. So there is a little girl here standing at point A who finds an air balloon. So again this forms a right angled triangle. So what does she do? She goes and calls her mom and comes back to the same place, right? So by the time she goes and comes back with her mom and stands here at the same place A, this air balloon would have moved here, okay, right? So now so this again forms another right angled triangle, right? So is it possible to find out the height of the air balloon? So these are some of the examples given here, and in all these 3 cases we observe that there is a triangle, but most importantly there is a right angled triangle, okay? So now to find the trigonometric ratios, we consider a right angled triangle. So to find the trigonometric ratios, we consider a right angled triangle. So let me consider a right angled triangle A, B, C. Okay, so this is a right angled triangle, and we need to find some trigonometric ratios. So this is at an angle 90 degrees, okay? So we find trigonometric ratios with respect to angle A. So it can be with respect to angle C, so we consider with respect to angle A, right? So this is some angle. So what is angle of A? I have no idea. It can be 20 degrees, it can be 30 degrees, it can be 45 degrees. So there is some angle, A has some angle which is unknown. Okay, so with respect to A, we find a few trigonometric ratios. Now for that, when we consider a right angle triangle, there are of course a few properties. The side which is opposite to 90 degrees is known as the hypotenuse. Right? The angle considered is at A. So this is at angle A. So this side BC happens to be the side opposite to angle A. Right? And this is the side AB which is adjacent to the angle A. So this is the side adjacent to angle A. Right? So this angle A, which can be referred to as CAB. CAB. So this is angle A. So with respect to angle A, AC is of course the hypotenuse. With respect to angle A, AB is the side adjacent to angle A, and BC is the side opposite to angle A. Now with these three, AB adjacent side, BC opposite side to angle A, and hypotenuse, we define a few trigonometric ratios. So what are the trigonometric ratios? So the most important relations are the sine of angle A. Okay, so this is the sine of angle A. So this is all with respect to a right angled triangle. So this is side adjacent to angle A. So the sine of angle A is the side opposite to angle A, the side opposite to angle A divided by the hypotenuse. Okay, so the side opposite to angle A divided by the hypotenuse. So what is the side opposite to angle A, which is BC, divided by the hypotenuse is AC. So next we define the cosine of angle A. It is the side adjacent to angle A divided by the hypotenuse. So what is the side adjacent to angle A? It is AB by AC. So next we have the tangent. So we have the tangent of angle A. So the tangent of angle A is the side opposite to angle A divided by the side adjacent to angle A, which is the opposite side is BC divided by the adjacent side is AB. Okay, so these three relations are very important. So I have, let me repeat, with respect to angle A, sine of angle A is the opposite side BC by the hypotenuse AC. The cosine of angle A is the side adjacent to angle A, which is AB by the hypotenuse AC, and the tangent of angle A is the side opposite to angle A, which is BC, divided by the side adjacent to angle A, which is AB. So now we have three other relations which are reciprocals of sine, cosine and tangent. Okay, so what are they? So I have cosecant of angle A. The cosecant of angle A is nothing but 1 by sine of angle A. So that's going to be AC by BC. Cosecant. Next I have secant of angle A is nothing but 1 by cosine of angle A, which is AC by AB. So similarly we have the inverse of tangent A, which is cotangent. Cotangent of angle A is 1 by tangent of angle A, so which is AB by BC. Right? So we have observed that there are three basic relations, which is sine, cosine and tangent, and there are three other relations which are inverses. Inverse of sine is cosecant, inverse of cosine is secant, and inverse of tangent is cotangent. So how do we represent this? Instead of writing sine, cosine, there are some short forms which are written. So sine of angle A is represented or written as sine A. Cosine of angle A is represented as cos A. The tangent of angle A is represented as tan A. The cosecant of angle A is represented as cosecant A, C-O-S-E-C-A. The secant of angle A is represented as secant, S-E-C of A, and the cotangent of angle A is represented as cot A, C-O-T-A. So this is nothing but an abbreviation or a short form of writing sine, cosine, tangent, cosecant, secant and cotangent. Okay, so this is all with respect to the angle A. So now let's try to understand another important problem. So I have sine A, cos A, tan A. Their inverses for sine is cosecant A, for cos is secant A, and for tan is cot A. Now given a right angle triangle A, B and C, right? Now what is tan A? Now tan A is opposite side BC by AB. Now tan A can also be written as sine A by cos A. Why is that so? What is sine A? Sine A is opposite side by hypotenuse. The opposite side is BC by hypotenuse is AC, divided by cos A is adjacent side AB divided by the hypotenuse AC. Right? So these two can be cancelled. So I get BC by AB. So this is something which is very important. So sine by cos is tan A. So similarly, cos A by sine A is definitely cot A. Now let us consider a right angle triangle APM. This is a right angle triangle. Let me extend this to form another right angle triangle, which is ABC. Extend this to form another right angle triangle QN. Now let me try to find sine A with respect to the first right angle triangle APM. Now what is sine A? Sine A is nothing but opposite side, which is PM, by the hypotenuse AP, and this is also equal to the, if I consider the triangle ABC is also equal to BC divided by AC, which is also equal to QN divided by AQ, right? So here we find that the sine values, the trigonometric ratios remain the same irrespective of the lengths of the sides of the triangle, right? So here we find that the angle A is common for all the three triangles. This is 90, so definitely the angle B, angle C and angle Q will also be equal. So therefore I have sine A, which remains common for all these three right angle triangles, and similarly cos A. What is cos A for the first right angle triangle APM? It is AM adjacent side by AP, which is also equal to the adjacent side AB divided by the hypotenuse AC, which is also equal to the adjacent side AN divided by the hypotenuse AQ, right? So the values of the trigonometric ratios of an angle do not vary with the lengths of the side of the triangle, okay, if the angles remain the same. So this is a very important property which has to be remembered. So let us go through a few examples before we solve the exercise problem. So these are some of the examples given in your textbook, and let us see how these examples have been solved. We'll go through them once again, and then in the next session we will try to solve all the exercises given in the textbook, right? So let us see example 1. So what does example state? It states that tan of BC by AB equals 4 by 3, and we need to find the other trigonometric ratios. So I have a right angle triangle A, B and C. So this is the right angle triangle given. Tan A, so this is 90 degrees. Tan A is BC by AB, right? So the ratio is 4 by 3, right? So let this be 4K and 3K. The ratio is 4 by 3, so the length need not be 4 and 3. So the length can be 8 and 6. The length can be 12 and 9. Okay, so it can be a multiple of 4 and so if I multiply 4 and 3 with a constant k, which is a positive number, if I take the ratio, it is going to be 4 and 3. So BC is 4k and AB is 3k. So when I take the ratio, I get tan A, which is 4 by 3. So our job is to find all the other trigonometric ratios. So what are the other trigonometric ratios? So here BC is 4k, AB is 3k. So BC is 4k, AB is 3k. Now this is a right angle triangle. So applying Pythagoras Theorem, I have AC square is AB square plus BC square, right? So therefore, what is AC? So AC square is 4k square plus 3k square. So therefore you get 16k square plus 9k square, which is 25k square. So what is AC? Is root of 25k square. So root of 25 is 5. So I get 5k. So AC is 5k. So now we can find all the trigonometric ratios. So what are the trigonometric ratios? Sine A. So what is sine A? Opposite side BC divided by hypotenuse AC. So this is 5k. So 4k by 5k. So this is 4 by 5. So next I have cosine A, which is adjacent side AB divided by the hypotenuse AC. Right? So you have adjacent side AB divided by hypotenuse AC, which is 3k by 5k. So we get 3 by 5. So tan is already known. Now what is cosecant? Is 1 by sine. So it is 5 by 4. Similarly, what is secant? Secant is 1 by cos A. Cosecant A and secant A, which is 5 by 3. And what is cot A? Cot A is inverse of tan A. So cot A is 1 by tan A, which is equal to 3 by 4. So we have found out all the trigonometric ratios. So this is the first example, which is very simple. So now we have the next example. So given two right angle triangles, so there are two right angle triangles. The first one is ABC and the next one is PQR. Okay, so it's been said that sine B is equal to sine Q. Okay, so we need to prove that angle B equals angle Q. Okay, so this is very simple. So I have sine B. What is sine B? So it is opposite side by adjacent side, right? So sine B is opposite side AC by the opposite side by the hypotenuse AB. So sine B is opposite side by hypotenuse, which is AC by AB. Next I have sine Q is opposite side PR divided by the hypotenuse QR. Okay. Now it has been said that these two are equal, right? So sine B is equal to sine Q. So what do? I equate them. So AC by AB is definitely equal to PR divided by PQ, and let me call this as K. Right? So now from this, can they be interchanged? Yes, so let me bring this here. So AC by PR, okay, so I bring AB on top, is AB by PQ, which is equal to Q. So let me call this as 1. Right? So the ratio still remains the same, and this ratio is equal to K, a positive integer, okay, a positive value. So let me call this as 1. Right. So now this forms a right angle triangle. So by using Pythagoras Theorem, I have AB square equals AC square plus BC square. Okay, so let us try to find what BC is, because BC is missing here. So let us try to find what is BC. So what is BC? It is nothing but AB square minus AC square, the whole under root. So similarly here, QR, which is the adjacent side, is again equal to PQ square minus PR square. Right? So I hope this is clear till here. This again we have got by using the Pythagoras theorem. Right? So I have BC equal to this, QR is also equal to this. So now let us take the ratio of these two, BC by QR. So BC by QR is nothing but equal to root of AB square minus AC square divided by root of PQ square minus PR square. So now the question is, what is AB and what is AC? Now can I represent AB and AC in terms of PQ and PR? Yes. Now if I consider AC by PR is K. So therefore AC equals K times PR. AB by PQ is equal to K. So what is AB? AB is K times PQ. Very simple. So let me substitute these values for AB and AC here in this. So I have AC. So I have BC by QR. What is that equal to? What is AB? AB is KPQ. K square PQ square minus AC square is K square PR square. The whole root divided by root of PQ square minus PR square. Now why is it that we have done this? So that we can eliminate the common factor. So K square is common in the numerator. If I take it common, I would get K square into PQ square minus PR square, the whole root. So taking K square outside the root, I will get K root of PQ square minus PR square divided by root of PQ square minus PR square, which is BC by QR. So these two can be cancelled, so it is equal to K. So BC by QR is also equal to K. Okay. So now what is the question now? You have AC by PR equals AB by PQ is also equal to BC by QR, which is equal to K. Right? So we find that the ratios of the sides AC by PR is equal to BC by QR is also equal to AB by PQ. Right? So we find that the ratios of the sides are the same for all the three sides. So therefore we find that the triangle ACB is very similar to the triangle PRQ, and therefore we conclude that the angle B must be equal to angle Q. Right? So it's fairly simple problem. So let's move on to the next. So there is a triangle, right angle triangle ACB, which is right angled at C. Okay, so I have ABC and it is right angled at C given. AB is 29 units, BC is 21 units, and the angle ABC is theta. Okay, now what is this theta? Theta is some value of the angle. Okay, so it is an unknown. I don't know the angle of B, so I call it as theta. So theta is basically an unknown value. Instead of theta, you can call it as x, y, z. So a general way of calling an unknown angle is theta. So we need to find cos square theta plus sin square theta, and 2 cos square theta minus sin square theta. So this is a right angle triangle. So from Pythagoras theorem I have AB square, which is AC square plus BC square, right? So what is AC? It is root of AB square, 29 square, minus BC square, which is 21 square. So this is like A square minus B square, which is A plus B into A minus B. So I can write this as 29 plus 21 into 29 minus 21. So here I get 50, and here I get 8. So 50 into 8 is 400 root. So you get 20 units. So AC is 20. Right? So once the value of AC is known, we can find the value of cos and sin. So what is cos theta? It is adjacent side, which is 21 divided by 29 hypotenuse. And what is sin theta? It is opposite side of B, which is 20 divided by 29. Okay, right? So cos theta is the adjacent side BC by AB. Sin theta is opposite side, which is AC by AB, the hypotenuse. So now let's take the first expression, cos square theta plus sin square theta. So what do I get? So we get 21 by 29 the whole square plus 20 by 29 the whole square. So denominator is common. So 29 square, 21 square plus 20 square. So what is 21 square? 21 square is 441. 20 square is 400. And 29 square, you can multiply and check, you would get 841. So you add these two, you get 841. 441 plus 400 is 841. Divided by 841 equals 1. So this is a very important relation, which is always true. Cos square theta plus sin square theta is equal to 1. Okay, so this is a very important relation and we have proved it by an example. So next, let us see cos square theta minus sin square theta. Right? So what do we get here? So we get 21 by 29 the whole square minus 20 by 29 the whole square. So you have 29 square, which is 841. So this is 21 square minus 20 square. Right? So this can be written as A plus B into A minus B. 21 plus 20. 21 minus 20 divided by 29 square. So this is 41 into 1 divided by 841. So we get 41 divided by 841. Okay. So in this example, what have we observed? We have got a very important relation. which is sine square theta plus cos square theta equals 1. So next, there's a right angle triangle ABC with angle A here. So if tan A equals 1, we need to verify that that 2 sine A cos A equals 1. Okay, so this is what needs to be verified. So tan A is 1. So what is tan A? So tan A in general is opposite side by adjacent side. Opposite side to A is BC. Adjacent side to angle A is AB. So this is 1. So therefore, so this is basically a ratio, isn't it? So it is 1 where both of them are equal. AB is equal to BC, right? So therefore, let's assume that AB is equal to BC is equal to some value K. These two sides are equal and is equal to some value K. So if I take the ratio, I will get K by K, which is 1. So tan A will be 1. Right. So let us calculate all the sides here. So I have AC square, which is hypotenuse square, which is AB square plus BC square. Now what is AB and BC? AB and BC is K square plus K square. So what is AC? AC is root of 2K square, which is K into root 2. Right, it's K into root 2. So now let's get all the values here. So what is sine A? Sine A is opposite side BC divided by the hypotenuse AC. What is the opposite side BC? BC is K. AB is K. And now AC is K into root 2. That is what we have calculated, right? So BC is K divided by AC, which is K root 2. So I get 1 by root 2. So similarly, I have cos A, which is adjacent side AB divided by the hypotenuse AC, which is again K by K root 2, which is 1 by root 2. So I've got the value of sine and cosine, which is 1 by root 2 and 1 by root 2. So now let's substitute the values here. I have 2 sine A cos A, which is 2 into what is sine A? 1 by root 2. Cos A is also 1 by root 2, which is equal to 1. So we have verified the result. So if tan A is 1, then 2 sine A cos A is also equal to 1. So this is again a very important relation. Okay. So next, let's see example 5. So there is a right angle triangle which is P, Q and O, right angled at P. Given OP is 7 centimeters and given OQ minus PQ equals 1 centimeter, find sine Q and cos Q. Right, so this is what we need to find. Okay. So this is a right angle triangle, so we know that OQ square is PQ square plus OP square. Right? Now from this, we also have OQ equals 1 plus PQ. Right? So if I take PQ to the other side. So OP is known, which is 7 square. OQ is unknown. PQ is also unknown. But what is OQ? OQ is nothing but 1 plus PQ. So in place of OQ, I will write 1 plus PQ square plus PQ square. Right? So in place of OQ, I am writing 1 plus PQ square, which is equal to PQ square plus OP square, which is 7 square. So expanding this, so this is a plus b the whole square, which is a square plus 2ab plus b square. So I get a square, which is 1 plus 2pq plus pq square equals pq square plus 7 square is 49. So pq square I can cancel. So let this 1 go to the other side. So I get 2pq equals 49 minus 1, which is 48. So PQ equals 48 by 2, which is 24. Okay, so PQ is 24 centimeters. If PQ is 24 centimeters, what is OQ? OQ is 1 plus 24, which is 25 centimeters. So this is 24 centimeters. 25 centimeters is OQ, which is the hypotenuse. So I need to find sine Q. So what is sine Q? Sine of angle Q, which is opposite side OP divided by hypotenuse OQ, which is 7 by 25. Next, I need to find cos Q. So what is cos Q? The adjacent side is PQ divided by OQ, which is 24 by 25. Right? So in this session we have worked the examples given in the textbook, and in the next session we will try to solve all the exercises given in the textbook. Right? So trigonometry basically is a very interesting and a simple topic. Initially you need to practice problems again and again, but mind you, it is a very simple topic if you understand the basic concepts and remember the trigonometric ratios. Thank you.